the stars. Amazing. Life-giving. And life-ending. Since the dawn of the universe, the stars have created and destroyed in a repetitive cycle. It is the heartbeat of the cosmos. They are responsible for producing the light and heat that makes life possible on Earth. But those same stars that give life can sometimes come to an explosive end. Stars start their lives as cold, dense globes of gas. Slowly, they contract under their own gravity until nuclear fusion ignites in their cores and they become stable, shining beacons in space. The life cycle of a star can last from millions to billions of years. Normally, the larger the star, the quicker it uses up its hydrogen fuel in a process called fusion. Hydrogen atoms are smashed together under enormous pressure, creating an outward force, and in doing so create helium and energy. A star is constantly pushing outward as gravity is pushing inward. These two forces balance out in what is called hydrostatic equilibrium. Stars more than 8 times the sun's mass will burn their fuel quickly, but will transition to another fuel as they deplete it. Its core contracts, growing hotter and denser until the previous nuclear reaction's leftovers undergo fusion itself. As each fuel source runs out, the star's core reverts to a different fuel source in sequence. Hydrogen, helium, carbon, neon, oxygen, and finally silicon. We can tell because the newest fuel stores less energy than the previous ones. This means that the star burns through it more quickly when it releases this type of fuel. In addition, once carbon ignites and the core's temperature approaches 1 billion degrees, neutrinos form and escape in greater numbers. Neutrinos don't interact easily with other matter and quickly move towards the edge of stars, out into space. To compensate for the energy loss, the core burns its nuclear fuel even faster. A star could take 10 million years or even longer to burn through its initial source of hydrogen. It will consume its helium in 2 million years and its carbon in just 2,000 years. The last phase, when the core fuses silicon, lasts less than 3 weeks. As the fusion of silicon concludes, a nickel and iron core roughly the size of Earth and about 1.5 times the mass of our Sun inhabits the center of the star. Iron elements have nature's most tightly bound nuclei, so the core cannot use this as fuel. As neutrinos surge from the star's core, its density becomes so high that it forces electrons, the star's main source of pressure, inside nuclei. Electrons alter some protons into neutrons. Surging neutrinos, compressing protons and electrons together, begin to remove the pressure that supports the star's hydrostatic equilibrium. The star has no new energy sources to tap and now succumbs to the effects of gravity. The dying star implodes incredibly fast, about 25% the speed of light. In less than 15 seconds, it collapses from a star that is 1,000,000 times the mass of the Earth to a hot, dense proto-neutron star just 20 miles across. When a star collapses so quickly, an enormous burst of energy causes the outermost layer of the star to explode in an incredible blast called a supernova. A Type 2 supernova can happen in binary star systems where at least one of the stars is an Earth-sized white dwarf. A white dwarf is created when a low-mass star has used up all its nuclear fuel and sheds its outer layers as a planetary nebula. They are small, very dense, and typically the size of a planet. White dwarf temperatures can exceed 180,000 degrees Fahrenheit. When a white dwarf star grows too large from drawing in matter from its nearby star, or collides with a binary celestial object, it can explode in a massive supernova. A supernova is so bright it can outshine entire galaxies for days or even a few months. They can easily be seen across the universe like grand fireworks of the cosmos. These explosions are among the largest releases of energy observed in the universe. A hot cloud of gas or nebula is left behind, along with a very dense core. An outward expanding ring of material is created. The supernova of a star more than 10 times the size of our Sun may leave behind the densest object known in the universe, a black hole. In galaxies like our own Milky Way, astronomers believe that about 2 or 3 supernovas occur each century. As the universe contains innumerable galaxies, astronomers observe a few hundred supernovas from outside our galaxy each year. Stars convert simple elements like hydrogen into heavier elements. These life-depending materials, like carbon and nitrogen, are derived from this fusion reaction in stars. Supermassive stars can make heavier elements like gold, silver, and uranium. Stars distribute newly created elements throughout space when massive supernovas occur. The process of star formation takes around 1,000,000 years. Stars start as a vast cloud of gas, which eventually collapse due to gravity. Once this protostar has collected enough mass, the process of nuclear fusion sparks life into a new generation star. If the star has a mass relative to our own Sun, its life cycle can exceed 10 billion years. Looking up at the stars can make you feel a connection to our past that dates back thousands of years. We owe the stars our lives. In fact, every molecule that makes up our bodies was forged inside the heart of a star, truly making us all children of the stars. Stars are not just an object to behold. They are also the most beautiful and poetic objects in the universe. Whether it's a supermassive star shining the cosmos like a beacon of hope, or a small brown dwarf star almost impossible to see, every star is incredibly beautiful and tells a story. Thanks for watching. Please like and subscribe for more wonder.